All right, so this practice problem looks at energy usage and power. And it reads, what is the cost of operating a 3-watt electric clock for a year if the cost of electricity is $0.09, so 9 cents per kilowatt hour? So like if you have one of those clocks that are plugged into the wall, how much is it really costing to operate that for the whole year? Well, we want to recognize that the power, we want to remember our power is equal to our energy per time. So the energy used is going to be whatever that power is times the amount of time that we're using that object for. Okay, well, we are given that this is a 3-watt electric clock, but our energy usage is in kilowatt hours. So we need to kind of recognize what both of those means. And the first thing we want to recognize is how many hours are there in a full year. So we have hours per year because we're going to need to know how much kilowatt hours is occurring in that year. So how many hours are in a year? How many hours per year? Well, we know that there are 365 days in one year. And we know that there are, in one year, we have 24 hours. That is not what I want to do. We do not have 24 hours. I don't know what I'm doing that. 365 days in a year. And there are 24 hours in one day. That's what I need to get rid of. And so we know that there are 8,760 hours in one year. And that number is going to be important for us in just a minute. So that's how long we are going to be using that for. So it tells us that it's a 3-watt electric clock. And so our power is equal to 3 watts. And again, we are given the problem in kilowatts. That is 3 times 10 to the minus 3 kilowatts. All right, so the power of that microwave is 3 times 10 to the minus 3 kilowatts. So we do that for that many hours. The power times the amount of time is our energy used. So the power, 3 times 10 to the minus 3, times the amount of time, 8,760, is equal to our energy used for that year. Our energy used is 26.28 kilowatt hours. So that's how much energy is used by that 3-watt device over the course of a year. Well, the amount of cost then, our dollar amount, is equal to the energy used times the cost per energy used, which we're given in the problem. So our cost per energy used, we said, was 0.09 per kilowatt hour. So 9 cents per kilowatt hour. So our total cost will be 0.09 times the energy used of 26.28. And we find that to run that clock, it costs about $2.90 for that whole year. All right, so using this power idea, recognizing that the power of the product times how long we run it for gives us the total amount of energy used in that particular situation. And then we're just looking at how much we're charged for that energy. All right, good job.